Today we're going to learn what is the appropriate measure of variable relationship when two variables do not share a linear relationship. The example I'm going to use is here. So there's a basketball player, and the number of points he scored per game seems to be related to how important he thinks each game was. So I have two variables in my data set. One variable is the perceived importance, which has a level from 1 all the way to 6, with 1 being not important, 6 being the most important. And the second variable is how many points this player scored during that game. Before you get any measure of variable relationship, it's important for you to understand what kind of variables you have and how they're related. In our case, the perceived importance could be a quantitative variable, and number of points is a quantitative variable as well. This one, if you prefer, you can call it ranked variable because it only have 6 levels. Still, we need to check the relationship between the two variables. So we're going to go to the scatter plot place. And we have only two variables. So select the simple scatter plot. I'm going to treat my perceived importance as the independent variable. So put it on the x-axis. And the number of points this player scored as the dependent variable, I'm going to put on the y-axis. Nothing else we need. We just want to verify whether the two variables has a linear relationship. Well, according to the output, the scatter plot does not show a linear relationship between the two variables. You can see here that when the importance goes up from 1, 2, 3, all the way to 4, the points scored per game seems to goes up as well. But after that, when the importance goes up from 4 to 6, the points started to go down. So there is a curvilinear relationship between the two variables. So Pearson R or Spearman rule is not the right measure when you have a curvilinear relationship between the two variables. So in order to get a good measure of this curvilinear relationship, we go here, Analyze, Descriptive Statistics, and Crosstabs. Okay. And you can put the two variables, one to the row, the other to the column. Doesn't matter which one goes where. Then you go to this place called Statistics, and you want to check Eta, which is a measure here says nominal by interval. Later on, we'll explain why it's labeled like this. And you click OK, and you can see that you're given an output. The first is summary. You have 15 observations. And then the second table here, you have the perceived importance that goes as the row, and the number of scores per game that goes into the columns. The last table gives you the measure of Eta. You have two values, and you want to rate the value that is consistent with which variable you think has been used as your dependent variable. In our case, we think the perceived importance was the independent variable, and number of points scored is the dependent variable. So when you have point as a dependent variable, the Eta is 0.963. The Eta coefficient as a measure of nonlinear relationship between two variables can be used to measure the nonlinear relationship between two continuous variables, or between one ranked variable versus a continuous variable. In our particular example, you can see the perceived importance has only 6 levels. What happens if you have a variable that's both are continuous? Literally, you pick the one that you think can be used as an independent variable and cut the variable into somewhere between 6 to 12 intervals. And this is how you get the eta measure. If I show you here, I do a one-way ANOVA with the importance as the independent variable, the points scored as a dependent variable. And you can see that here we have the sum squared between, which is 238.9, and sum squared total, that's the total variation in this data set, which is 257.73. Remember that in one-way ANOVA, eta squared is a measure of effect size, which is the sum squared between, and we have a value of 238.9 over sum squared total. Okay, so that's our eta squared. Now, eta is the square root of eta squared. So eta coefficient is the value we find the square root. So we have a 0.963. That's what we get here as the measure of nonlinear relationship. Okay. So this means the strength of association between the perceived importance and the points scored per game is as strong as 0.96. We know eta has a value somewhere between 0 and 1. The closer it is to 1, the stronger the relationship is. In my case, I did not have to convert any of the variables into nominal variables because the perceived importance already only have 6 values. Just for the purpose of comparison, if you were not aware that the two variables, the importance and the point scored, had a nonlinear relationship, you jump into, okay, let's just use Pearson R or Spearman rule, since you have one variable that is ranked variable, to measure the relationship. You can see that the value is 0.506 for Spearman rule and only 0.418 for Pearson R. In both cases, they severely underestimated the strength of the relationship between the two variables.